When moving to the cloud, and especially in fast-paced DevOps environments, securely connecting to your private resources could be very challenging. And if you and your team want to be able to do that from basically any device like PCs, phones, tablets, etc. in an easy way, keeping a zero trust kind of solution and without a very complex, very expensive VPN, well, I would usually say good luck. Today, however, I have a solution to that for you. A service that allows you to create secure networks between your computers, servers, and cloud instances, even when separated by firewalls or different subnets. And that just works. Oh, and you can start with that for free. Let's talk about Twingate. Hey, welcome back to CoderDave, where we try and do DevOps just better. Today we talk about Twingate, which, as I said in the intro, is a service that allows you to securely connect to your private resources and keep them safe. Quick disclaimer, this video is sponsored by Twingate, but they don't have control what I'm allowed to say or not say in this video, and all the opinion expressed are my own. And in fact, you will see later on that while I generally like the service, and it's one of the reasons why I'm doing this video for you so you can discover it, I also have some points that I would like to see improved. With that out of the way, let's see first why we would want to adopt a zero trust networking solution like Twingate over a normal VPN. And for me, it goes down to 4 pillars: security, performance, maintainability, and user experience. With normal VPNs, user access is granted to the whole network that the VPN connects to, and therefore secure access to applications need to be managed using complex routing or by the application themselves. Twingate instead allows you to control access granularly at the application level, not the network level. And the access is granted on a per application basis. Moreover, access to specific resources can be based on a wide variety of factors, including an identity authenticated by a third-party SSO or identity provider using multi-factor authentication, the user's physical location, time of day, device, and other contextual data. Finally, Twingate provides comprehensive logging in a single centralized view, making monitoring way easier. Let's talk now about performances. If you've ever used a VPN, you probably know that usually that comes at a cost of latency or network performances in general, but not with Twingate. Because in fact, it uses something that they call, I believe, smart routing, and that allows much better performances over traditional solutions. And it works on 3 different levels. First one is resource level split tunneling. With a normal VPN solution, unless you have complex rules in place, all traffic is sent to the VPN gateway and flows through it. With Twingate instead, only the traffic that needs to go to the private endpoint is sent through the service, meaning that all your non-private traffic is not affected. We then have the NAT traversal. Traditional VPN clients are relatively limited. They relay information to a VPN server, and it's the job of that server and other network infrastructure to process authorization requests and manage traffic routing. Twingate instead pushes these processing activities to the network edge by making the client intelligent and creating peer-to-peer connections between clients and resources to minimize latency. And the final point about performances has to do with how the traffic is managed. Instead of using single plexing, which basically queues the traffic in a single stream and therefore causes performance degradation, Twingate delivers concurrent data streams by multiplexing them over a single connection. In general, Twingate is able to improve connectivity performances to your private resources and reduce network bandwidth usage on your corporate network. I mentioned before that another point I consider an advantage of Twingate over traditional VPN solutions has to do with the deployments and maintainability of the platform. And we will see in a moment how easy and quick it is to deploy Twingate, and it is something you don't actually usually have with normal VPNs, but it doesn't stop there. Twingate provides a centralized admin console which controls access to private resources throughout the organization, regardless of whether they are inside or outside the traditional network. Not much maintenance is needed on the connectors you deploy, and the service uses an API-first approach, so you can automate the configuration, make it part of your CI/CD, and even you can use Terraform to manage them. I don't think I need to add much more to what we've just seen to understand why I consider this having a better user experience over traditional VPNs for both admins and actual users. Before we see this in action, I want to spend just a few seconds talking about the overall architecture of the service and its components, and Twingate relies on 4 main components: the controller, the clients, the connectors, and the relays. The controller is the central coordination component for Twingate. It stores configuration changes via the admin console, registers connectors, and issues authorizations to clients making connection requests, amongst the other responsibilities. The client instead is installed obviously onto user devices and acts as a combined authentication and authorization proxy for user requests to the private resources. The client is where actually most of the decision-making processes happen in a Twingate network deployment. As we said, another component is the connector, which is deployed inside your private network and takes care of validating the client connections and performing local DNS resolutions, among the other things. And finally, the relay is the simple component in the Twingate architecture. No data or network identifiable information is stored in the relay, and no data carrying connections are terminated at the relay. It basically serves as a registration point for connectors and as a connection point for clients. Alright, enough talking, let's see this in action. We will start from scratch and we will install the connectors and the clients, and we will see how we can use all of this together. Let's take a look at what I have for testing this out. I will use Azure as my platform of choice, but of course this will work with any kind of private resource. I have this Windows VM, and if you go to networking, we can see that it doesn't have any public IP. It does have a private IP only, and it's into this private VNet on the default subnet. I also have this Linux VM, which once again doesn't have a public IP, only has a private IP, and it's in the default subnet of the private VNet virtual network. And if we take a look at the virtual network, we can see that only those 2 VMs, the Linux private and the Windows private, are connected to this network. We can see that there are no other subnets, and this VNet is not paired with anything else. So no VPN, no express route or anything like that. As I've mentioned before, I will use Azure, but this will work with any kind of private resource on cloud, on-prem, and anywhere else, as long as you use the proper connector to use the service. And speaking of connectors, let's see how we can set them up. When you go to the Twingate portal, you can sign in. And if it's your first time, you can create a new Twingate network, which basically creates your account. Or if you've already created your account, you can just specify its name, which will be in my case, coderdave.twingate.com, and log in. And after login, you'll be in the dashboard. Now we will see later all of the different tabs over here, but let's try and connect to our VMs. First thing you need to do is create a new remote network. You can select the provider, in my case Azure, but you can see we can connect to AWS, Google Cloud, on-premise, or anything else. I select Azure and I'll give it a name. It can be basically anything you want. Before we can add starting resources, we need to deploy the connector. If you remember from the diagram we've seen before, the connector is the thing that allows you to, as the name say, connect to your private network. You can just deploy a connector or click on add. I will deploy one that is already here. And I can select the type of connector I want. I can run it in Docker, Helm, natively on Azure, on a Linux VM, on ECS, on EMI in AWS, or manual installation. Those will be all the same component, it just changes where it runs. For example, I can pick Docker if I have a VM in my network that already runs Docker and I just want to run a new container on there. I can use Helm if I want to deploy that in a Kubernetes cluster or anything like that. In my case, I want to run it on Azure directly, so I select it. Next step is to generate the tokens for the platform. So I need to sign in again with the same method I chose before. Now I have my tokens generated. Now I need to populate this with the information on which I want to deploy the connector to. For Azure, which again is my provider of choice, it will be deployed as a container instance, and that requires to be placed inside a subnet in the virtual network. In this example, I want to use the private resources, which is the resource group we used before, private VNet, where my resources are, and I'm going to create a subnet specifically for the connector sub. So let's do it right now. Let's go to the subnets, new subnet, let's call it connector sub. All the rest is all right. And so we have our new subnet. Let's go back to Twingate. We can decide to enable custom DNS server for the connector if we need to, and also enable more logs for easier troubleshooting or connecting into a SIEM. Finally, as you can see, Twingate generates for us a script that deploy the container image on my Azure infrastructure, pre-populated with all the selections I've made, all the names I've filled in, like private resources, private VNet, and connector sub, and my access tokens. So what I can do now is copy this command, and I can go back to Azure, where I have my Cloud Shell, but of course I can execute this from any CLI, even local on my machine if I have the Azure CLI installed. I can paste the command and just execute it. This will take just a few seconds and will deploy the container instance with the Twingate container image that serves as my connector. While this runs, keep in mind that you may incur additional costs for running your connectors depending on the service you've chosen to deploy them. In my case, I've chosen to run them on the Azure infrastructure using the Azure Container Instances service, so I'll be billed for that. Same thing may apply if you run those in dedicated VMs or ECS clusters or other kind of resources. Not a big deal, but something to keep in mind to avoid surprises. The script is run and completed successfully. So what we can do now is going back to the Twingate interface, and in our connector status, we can see that it's connected. It's connected to both the controller and the relay, which are managed by Twingate. So if now I go back to my network I've created, we can see also here that the connector is connected. And I believe it's marked in yellow over here because we've deployed only one connector. They recommend deploying at least 2 connectors for HA. At this point, we can start adding our resources, which in this case will be the 2 VMs I've shown you before. Let's click on Add Resources, and we can select if we want to add them by DNS or by IP. First one was the Windows VM, and again, the label can be anything you want. And the IP for it was 10.0.0.4. Needs to be a CIDR, you need to have the /32. You can also add port restrictions to specify a single port you want to connect to. Let's leave it empty for the time being. Let's click on Add Resource, and here we can proceed with some access control. As I've mentioned before, Twingate allows you to have really fine-grained control over security of your resources, and the screen we've just seen is one of those in which you achieve that. In my case, I only have one group created so far, so I can select it and add this group as permissions to my resource. Let's quickly add the Linux VM. And here we have them. I can always change the assignments I made. For example, I can go into the Linux VM and change the access, or I can edit the resource, adding port restrictions, for example. I can disable some resources if I don't want users to connect to them and delete them as well. We will see more security rules in a second and play with devices, policies, and whatnot. But before doing that, let's install the client and see if we can actually connect to our resources. To install the client, just go to the twingate.com website and you have this download. There are clients available for basically every operating system: macOS, Windows, Linux, and even Chrome OS. And of course, for iOS and Android, you can either click on here or go directly to the marketplace on your phone or tablet. I'm running on Windows right now, so I will click Windows, and this will download the installation for the client. The installation will just take a few seconds, and after that, our client will be installed. All we need to do is enter the name of the network we've created before, the name of the account basically, and click on Join the Network. This will associate the client with your network. You'll have, of course, to sign into your account. And now we see that we have our Twingate client running. You can see the icon in the tray bar. And if we click on it, we can see what we can connect to. In this case are my Linux VM and my Windows VM. And we can change network if we have more than one. In this case, we only have one. We can decide if it started login, and we have documentation and other policies. It's interesting that it says subnetworks here, and we'll go back to this in a second. But since we are apparently connected, let's see if we can actually connect to our VMs. Let's start with the Windows VM. 10.0.0.4 was the IP of my Windows VM. Connect. It's asking me for the password, of course. And here we go. We are connected to the Windows private server that we've seen before in the Azure portal. And of course, we can do the same thing on the Linux VM, for example, with PuTTY. That was 10.0.0.5. And if we try to connect through SSH, we are in. This is cool, right? But let's see something even cooler. As I mentioned a moment ago, my resources were listed in the client as subnetworks. Let's play with it, shall we? What have I done here is removing the two single VMs I've added before as resources, and instead adding the whole subnet, the default subnet of my private VNet. As soon as I've done that in the client, I now have only one subnetwork, which in fact is my default subnet with the same address. What it means now is that I can still connect to all the resources within that subnet. And I have here connected already the Windows machine, but I can try again SSHing into the Linux one, 10.0.0.5, open, and as you can see, I can connect. This approach, of course, has both pros and cons. On one side, adding the whole subnet makes it way easier to share resources because you don't have to add individual IPs and DNS addresses. On the other hand, though, if you add the individual resources, then you will have a more fine-grained control over, authorization, authentication, and whatnot. Before we move on seeing how we can further strengthen the security on our resources, hit the like button below if you're enjoying this video or if you find it insightful. This will not only let more people benefit from it and seeing this video, but also would mean a lot to me. Thank you. So let's see how we can further secure our resources. First of all, we can go to Team, and here is where we do user management. We can invite a new user, we can create groups, we can assign administrators, and we can create service accounts. Let's start with this. Let's say I want to assign a service account to my GitHub Actions Cluster runners, so they are able to connect and deploy to my resources within my private network. When I do that, I can generate a service key, give it a name, I can define an expiration period, and generate it. Now I can download or copy this token, and with this, my service will be able to connect through Twingate to my resources. Still on the team side, of course, I can create another group, let's say restricted users. And just to try it out, let's leave it with 0 users. Let me go back to my subnet and change the access here to my restricted users. And let me remove the everyone group. In this moment, with my client, I shouldn't be able to connect. And in fact, if I try to connect to 10.0.0.5, which once again was my Linux VM, you'll see that the connection doesn't go through. Let me try to quickly change this. Let's add everyone. Let's try again. And now you see that the login window appears. So it's really immediate how the policies and access control is propagated to the client. Same thing I can do for my service account. If I want the GitHub Actions Cluster runner service account to be able to connect to this subnet, I can just select it from here, add it, and now this service will be able to use the resources in here. If you have many users and groups, adding them manually to Twingate will take a long time. But luckily you don't have to waste your time because the service supports the integration directly with your IDP. In the settings of Twingate, in fact, you have this identity provider menu. In here, you can connect Twingate with Okta, Google Workspace, Azure AD, or OneLogin. And when you do that, all the groups and users in your IDP will be synchronized
with the service. And at that point, you can add them to your resources.
Twingate has many other features, but this video is already quite long, so I want to cover only 2 more features that in my opinion are super cool. But let me know in the comment section below if you want to see more in-depth usage and use cases, and I will try and make a video about those. But let's go back to the dashboard.
As admins, we want to make sure that we have full security over our private resources, and Twingate really helps us with this. First of the 2 features I want to show you is the device list. Now, in this moment, I only have my client connected on my computer. I have a lot of information about the computer, about the account that this computer is serving, and also the version of the client that is installed. If I go to manage, I can decide to trust this device. What that means? Well, to understand this better, we need to go to see the policies. By default, there's only one policy that basically only has some sign-in requirement. But we can create new policies, and in here, we can set all the requirements for sign-in policy, for authentication requirements, and for device requirements. Since we were talking about devices, let's see the device requirements first. And when I add this, we can require to be able to connect. You need to be on a specific operating system, for example. We can mix and match whatever we want. For example, we don't want our users to connect to this specific policy or to the resources protected by this specific policy from mobile. We can add that as a requirement. Or we can add that connection must be only from trusted device. And this is where the trust device and the management of devices came from. We can also change the requirement for authentication, but we also have how frequently the client will require authentication. By default is 5 days, but we can even go down to every hour if we want to. Now, this is a little bit too aggressive, I think, but for very sensitive resources, make sense. But let's try to apply this policy to my scenario. What I have to do is going to team, going to my group, and in here, change the resource policy. Let's select this CoderDave policy and confirm. Now, if I go back to the devices, you can see that this is not yet trusted. And again, what this means is that if I try again to connect to my VM as I've done before, the connection is not going through. You see, connection refused. As soon as I trust this device, and I can see that it's trusted because I have this blue mark next to the name, you can see that I actually can connect.
This gives a lot of control to sysadmins and allows us to do a lot of things that are either impossible or very hard to achieve using normal VPN solutions. As I've mentioned before, there's so much more we could explore about this service. Like for example, using Twingate to remotely connect to your NAS, or using it to control access to staging environments, or even using to secure SaaS applications. But let me know in the comment section below if you want to see any of those use cases and more, and I'll try to make another video about it. Last but not least, let's briefly talk about pricing. And as I mentioned before, you can start using Twingate completely for free. And you can keep it free forever if you don't need more than 5 users or more than 2 remote networks. However, with the free plan, you will miss out on the most innovative and useful features. If you want to have resource level access policies or integrate with your identity provider, or if you need to have it rolled out to more users, more devices, or more remote networks, then you'll have to go to one of their paid plans. And as you've seen, that can be scaled to unlimited users, devices, and remote networks. But remember to factor in the cost of the connectors you need to deploy. Just keep that in mind. So what do you think about this service? I do like it, and I think it's on a whole new level if compared to traditional standard VPNs. However, there are a couple of things that I would like to see improved. I would like, for example, for Twingate to be able to utilize the cloud provider APIs to be able to provision automatically the connector in my subscriptions. While this may not apply to enterprise users, in fact, in the enterprise world, we like to have more control about what we deploy. So yeah, that's not a solution for enterprise. However, I think that smaller users, startups and smaller companies can really benefit from it. Anyway, I think that's more than enough for today. Let me know in the comment section below what you think about Twingate. and if you would consider using it over traditional VPN solutions, or perhaps if you're already using Twingate or other zero trust networking solutions. And finally, check out this video over here in which I talk about DevSecOps and how to do it properly. But that's it for me. Thanks so much for watching. I really hope you enjoyed it. Hit the like button below, subscribe if you haven't already, and I see you in the next video here at CoderDave.